Okay.
Okay. All right. Let's do this one first. All sodium salts are soluble in water. All nitrate salts are soluble in water. Okay. Barium carbonate is insoluble. So I've already told you to make an insoluble salt, you need to take soluble plus soluble. Correct or not? So you need to take barium something which is soluble plus something carbonate which is soluble. Okay? And the question already tells you all nitrates are soluble. So the barium nitrate lah. All sodium are soluble. So sodium carbonate. So that's how you actually do this. You always use nitrate and sodium. Right? And when this barium and this carbonate join together to form the solid, the leftover sodium nitrate will get together to form the aqueous. Okay? All right. So they are asking you how to do this reaction. So the first thing you do is in a beaker, mix 20 centimeter cube. You don't have to write 20, any volume also can. Okay? Of sodium carbonate solution with 20 centimeter cube of barium nitrate solution. Okay, stir with glass rod, then filter. Okay, stir with a glass rod and then filter. Okay, now after you filter, your insoluble salt will be who? The filtrate or the residue? When you filter, right? You pour already, you mix together, you filter. This is who? This would be the barium carbonate, right? Not the solid on top. What is the solid on top called? Residue. Okay. So wash the or rinse the residue with distilled water and dry between filter paper. Okay. All right. And then chemical equation, you can write the one above. You can write this one. Okay. Or you can write this one. Can also, the ionic equation also can. All right. Can? Okay. Like this, 5 marks already. It's very simple. Uh, ye practice writing. Can understand? Okay, Joe. Okay, Joe. Can understand?
Yep.
Okay, so the questions are very standard. They don't ask. Okay, remember, IG is very straightforward. It's not very complicated. Okay, it's very, very straightforward. Okay, nitrate is heated. Okay, this one is no longer in your syllabus, but let me write for you. Sodium nitrate becomes sodium nitrite and oxygen. It's thermal decomposition. Okay? Okay. The unbalanced chemical equation. Okay, so this one, right? I hope you got it correct. 2, 4. Okay, this one is the one that is tricky. You have to do 2 times 3. Okay? Not just 3. So you have to put 6 here. Okay, can? When hydrated copper 2 nitrate crystals are heated, steam is produced. When the steam condenses on a cool surface, it turns into colorless liquid. Remember, hydrated is always with water inside. Anhydrous copper 2 chloride is used to show that colorless liquid contains. Okay, so this one you must memorize. This one I taught before in equilibrium, right? So this one, it changes from blue to pink. There is another one. Okay, there's another one called copper 2 sulfate. Okay, all right. This is to test, okay, this one, remember, this is to test the presence. Okay, this one is to test the purity. Purity, you must test the boiling point. Boiling point is 100 degrees Celsius. Remember, pure water will only boil at a certain temperature. Okay, can I? Ijo, okay?
Yes.
All right. Okay. Copper 2 sulfate has the formula CuSO4. Okay. Copper 2 sulfate is a blue solution. A sample of aqueous copper 2 sulfate is made by adding excess copper 2 oxide to hot sulfuric acid. Complete the symbol equation. Okay. For this reaction, include the state symbol. So this one you should know lah. This one is the one where here is the acid and here you put the copper 2 oxide. Okay? Can? So copper 2 oxide solid, sulfuric acid. Okay, and then aqueous and the last one? Okay, water is liquid and this one is aqueous. Can? Can I? State one observation is added in excess. So you know you add and add and add and add until it doesn't dissolve anymore. Okay, so the logical answer is CuO does not dissolve anymore. Correct or not? Okay, but in marking scheme, okay, you must write solid. All right. Describe how aqueous copper 2 sulfate can be separated from the reaction. So this one is filtration lah. You can say filtration or filtering. Okay, can? Yeah. Crystals of hydrated copper 2 sulfate can be obtained from aqueous copper 2 sulfate by crystallization. What's mean by hydrated? Okay, this one, right? This one, you write a specific must write a specific term. You cannot write what you feel. Okay, so contains water molecules chemically bonded to the compound or to the salt. Okay, because that's what hydrated means, right? It's not solution, it means the water molecules are chemically bonded there and you feel it, it's a solid. Okay, hydrated copper 2 sulfate. Okay, you don't need to memorize this now, but there are three numbers. Hydrated is five. There are three numbers that you kind of need to memorize. Lah. Okay, so cobalt chloride hydrated is 6. Then iron 3 oxide hydrated is 2. Okay, so this, and these three must memorize. Okay, describe this how this crystallization is done. So this one you should know, we've done many times. Heat until saturated. Okay, and then what do you do? Cool to evaporate. Okay, and then dry crystals between, yeah. All right, can? Ijo, okay?
Okay.
Mm, why aqueous copper 2 sulfate conducts electricity? Why? It has free moving ions. Only metals can have free moving electrons. Ayo, every student gets this wrong, Only metals and also graphite is free electrons. Ionic compound is free moving ions, okay? So, why we use electrons made of graphite? Of course, they conduct electricity and they are inert, okay? Okay, you can understand? Okay, now this one, you cannot just do, okay, unless you are so good at it already, you cannot just look at the question. You must always draw. Okay, you must always draw to get the idea. So, appearance of electrolyte change during the electrolysis of copper 2 sulfate. And remember, they're using graphite. So, this one you should know by now. Okay, if you don't know, you just draw it to refresh your memory. In copper sulfate solution, there is copper ions, sulfate ions, hydrogen ions, hydroxide ions. Okay, so now copper ions, because it's transition metal, it will be chosen at the cathode. So the copper ions will become copper and stick here. Okay, at the anode, you will choose hydroxide ions and then it will form oxygen gas. So the electrolyte is copper 2 sulfate. Copper 2 sulfate is blue. The reason copper 2 sulfate is blue because of the copper ions. So now you have more copper ions and less copper ions. Less. So the become more blue or less blue. So you can either say the blue solution turns to colorless or the blue solution fades. Okay? Hey, Ijo, when do you finish exam?
24th.
24th you finish lah.
Yeah.
Okay, so November, December, we have more classes? Can Okay.
Okay.
Then we have more classes, and then after that, next year during your like first term exam, then we don't need to stress so much lah. Okay? Can? Okay. So when it's holiday, we catch up a bit more, and then when it's not holiday, then we maybe one of the holiday days we can come, and then the last 2 weeks of holiday you all can have a break. Something like that. Which week? You find out which week? We'll work around it, don't worry. Okay? Describe what is seen at the cathode during electrolysis of copper 2 sulfate. So I just told you here. Now this one you must say it's actually pink solids. Because when it's freshly made, it's pink. Okay? Reddish brown is no, reddish brown is bromine. Yeah, this one is pink solids. Okay. Anode is this one, hydroxide. This one, okay, this one you must memorize lah. I cannot do anything much. Okay. State two differences seen if the electrolysis is repeated using copper electrodes. Okay, so this one, again, same concept. You must draw. Okay, so remember for this one, copper becomes copper ion at the anode. Because now the copper is made from, the anode is made from copper, it will react. And then this copper ion will stick to the, so at the negative, at the cathode, it will be the opposite. Remember? Okay, so one becomes big, one becomes small. This one becomes small, this one becomes big. Two differences. So for this one, anode decreases in size or dissolve. And the color, does it remain same blue or different blue? It will be the same glue, will not change, remains the same. Okay? Because you take one in, you take one out, so it's same. Because this one also increase in size, right? Although it's just color change. Okay? So, electrolyte does not change. Okay? Okay, chapter 10 is very easy. It is also connected to what you learn in Form 3 science. Okay, chemistry of the environment. So what I'm going to teach you now is chemistry of the environment, chapter 10. Yeah. Okay. All right. Okay, can you write this down? Chapter 10. Wait, chemistry of the environment. What is chapter 5? Hayo. You know what? Let me take a screenshot and then you can use it. You do have the paper. Have I given to you before?
The one with the all the
There,
chapters.
there, 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 there. Oh,
We
the
have
chapter
it.
5 is just the endo-exo only. Okay, okay. Let me take a screenshot. Okay. Can? Yeah. Okay. So this is what happens. And okay. So the first thing you need to learn is in environment. Okay, this is a car, even though it's an ugly car. Okay, now what do we put inside the car? Petroleum. Petroleum is known as fossil fuels. Okay, petroleum is known as fossil fuels. Now, petroleum has to be a hydrocarbon, which contains carbon, hydrogen, right now. So the ones that we use in Malaysia is usually C8H18. Okay, so it's a hydrocarbon. Now, hydrocarbon burn in oxygen, produces carbon dioxide and water. Okay, can you try and balance the equation? Okay, so how to balance? 8 carbon, and then here's 18 hydrogen, so 9 water. Then you add together. 8 times 2 is 16. 16 plus 9 equals to 25. So here you can put 25 over 2, right? Remember? Then you can take the whole thing, double it up. Okay, now, the most important thing to remember is it produces a lot of carbon dioxide. Okay, any car that you have, unless it's an electric car, it will produce carbon dioxide. Okay, carbon dioxide increases the greenhouse, it's a greenhouse gas. So it affects the greenhouse effect, and this causes global warming. Okay, now if the combustion produces carbon dioxide and water, this is called complete combustion. Okay? Now, sometimes there is also incomplete combustion. Incomplete combustion happens when there is not enough oxygen. Okay, so when there is incomplete combustion, you produces carbon monoxide. Carbon monoxide is a toxic gas. Okay, can? All right, now what else happens is a car must have an engine, right? Okay, when you pour petrol, when you pump the petrol, you add in petroleum. Okay, do you add in oxygen or not? Do you pump petrol and then you add in oxygen? Of course not. The oxygen comes from the air. It gets sucked in. The air gets sucked in. Now, in our air, it is 21% oxygen, but 78% is what?
Nitrogen.
Nitrogen. Yes. Okay. 78% is nitrogen. Study until brain, brain, brain burst already, brain burn already. Okay, so the nitrogen will also be sucked in. Now, in the air, in natural cases, nitrogen is usually inert. Okay? All right. Okay, now, however, when the nitrogen and oxygen get sucked in, it will be forced to react because the engine is very, very hot. Okay? So, carbon dioxide is from complete combustion of fossil fuels. Carbon monoxide is from incomplete combustion of fossil fuels. When the nitrogen and oxygen react together, when it comes out, it becomes nitrogen dioxide. Okay? It can become nitrogen dioxide or nitrogen monoxide also can. We usually call this oxides of nitrogen. So these two are from nitrogen and oxygen in air, from air, sorry, react in hot engine. So we're not trying to make it, it's just an unwanted byproduct. Okay, can? Alright. Now, is nitrogen dioxide good or bad? Why? Why is it bad? It is a what? Hmm? It's a metal or non-metal oxide. So non-metal oxide will be
Acid.
acidic. Non-metal oxide will be acidic. Okay, can? Got it? Got it? Okay, so this one is acidic, So nitrogen oxide, nitrogen monoxide is, so it causes acid rain. And another problems it causes is photochemical smog. Photochemical smog is like when you see things is not clear like that. Smog, yeah, like smoke like that. Can? Okay. Inside fossil fuels, they contain sulfur. Why does fossil fuel contain sulfur? Because sulfur is found in dead animals. In animals, don't have to be dead, lah, but it's found in animals. So when the carbon and the hydrogen burn, sulfur also burn. Okay? Can? So when sulfur burns, it also releases another gas, a third gas, which is so many gases come out, right? Sulfur dioxide. So this is from burning of our fossil fuels because fossil fuels contain sulfur. Okay, FF fossil fuels. I know place to write already. Okay, so this causes acid rain, but not photochemical smog. So just one car already so many problems. Okay, fossil fuel. Ready? Now, so we already know from, okay, I draw another car because that car full already, okay? We already know from the car releases carbon dioxide, which is a greenhouse gas, right? Okay. Now, what happens is if you have a lot of cattle, okay, this is not a pig, this is supposed to be a cow. Okay, moo. Okay, cattle, right? In their stomach got a lot of bacteria will digest all the grass. So this causes them to release a lot of methane. So methane is not technically cow fat. A lot of people say, oh, cow fat, cow fat. No, it's not about cow fat. It's because of the bacteria inside the cow's intestines. So it's also caused by decomposing vegetation. Okay, can? All right. Now, can you tell me about global warming? You learn what? This is the sun, light energy hits the earth, and then it comes out as ther- thermal energy. So we call it thermal energy, okay? Now, the thermal energy is supposed to be going out into space, but we keep a little bit, okay? But now, with carbon dioxide and methane, they trap the thermal energy. Sorry, what? Okay, wait. Okay, you write this down first. Okay, job, I want to show you something. Okay. So what happens is, it's actually not difficult. This one is very, very easy. Okay, it's very, very easy. It's not difficult. You just have to understand which one belongs to what. That's all. Okay. So this is the thing you must remember. Okay. So when you talk about global warming, you must talk about, okay, this one causes global warming, right? No need to write this. Okay. The absorption. Okay, this is the part that you need to write. This one. I already wrote the first one for you. Okay. So how they cause global warming is the greenhouse gases, the two greenhouse gases, okay, the carbon dioxide and methane, okay, they cause the absorption, reflection, and emission of thermal energy. The light energy is converted to thermal energy, right? And then after that, the greenhouse gases will cause, they will absorb the thermal energy, they will reflect and emit the thermal energy. So less thermal energy is lost to space. So you have to use the word what? Thermal energy lah. Duh. Cannot use just heat. Why? Don't ask me. Thermal energy is more accurate. Okay. Hold on. Don't have what? Your year don't have year 11. Yeah, that one was last year. There's a gap year because, oh, very good. Not bad. Your one doesn't have a year before you, has 2 years before you need. Because it was COVID year, we didn't collect, because it's COVID year. So the year 11 quite tough, like half COVID, half like that. But still managed to go through lah. They did quite well. I think got highest in the world some more for something. Hmm. Not bad, not bad. Oh, quite good results. Okay, sorry. Ijo, you okay? Can you understand so far?
Yeah.
Okay. So this is global warming, okay? And my beautiful cow, okay? All right. So, uh, okay, we're done with this. Okay, so now we go to acid. So carbon, which one is worse? Carbon monoxide is worse or carbon dioxide is worse? Actually, monoxide. Carbon dioxide is slowly causes greenhouse gas. And we can get rid of it by planting more trees, reducing pollution, all that. We can get rid of it. But carbon monoxide is very dangerous. It's toxic. Okay, so what can cars do to overcome this problem? So the logical thing to do overall is, of course, to use less fossil fuels, right? Okay, use less fossil fuels. How? You can use electric car, you can use public transport, you can carpool, all these logical things that you learn in bio. Another one is, of course, use low sulfur fuels. Okay, we use low sulfur fuels. You can do something to the petroleum where you get rid of the sulfur. Okay, but the best way, if I want to reduce sulfur nitrogen dioxide, I can use something called a catalytic converter. This is what I'm going to teach you now. Okay, a catalytic converter. Okay, what is a catalytic converter? So like this, okay, this is the car. Okay, here's the exhaust, right? Here's the engine. Okay, I'm obviously drawing wrong direction, but doesn't matter lah. Okay, so basically, before this gas gets released, we put something here. The gas that gets released, right? We stop the gas by putting the gas through a catalytic converter. So the engine, after burning the fossil fuel, let's say produces carbon monoxide and nitrogen monoxide. We change it to carbon dioxide and nitrogen gas. Or, so this is option one, option one. Option two is carbon monoxide and nitrogen dioxide also becomes carbon dioxide and nitrogen gas. Okay, can you try and balance these two equations? Okay, balance ready? Okay. Teacher, carbon dioxide is still bad. Yes, but it's not toxic. Carbon monoxide is toxic. And nitrogen is completely harmless. Okay. You must always balance the element last. Right now. Mhm. So, if you just have half of this, isn't everybody happy? So you just have to do two, 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 one. Ta-da! See, I'm so clever. Got it not? Right not? Now if I do like that, is it correct? Two, two, two. Harrison, how? Not necessarily. Is it? Hmm? You want what? Four? If you have four here, you must put two here and you must put four here. Is it correct? Four? No. Yeah, no. How to do it? So, four, two, two. Okay, let's see. We're gonna have four, two, two because it's carbon. Think some more, think some more. Okay, CO2. And then if this one, okay, so it's a one, two, three, four, right? So one, two, three, four, right? Oxygen correct already, right? So this one half lah. Ah, so four, two, four, one. Is it correct? You try and see. Four times plus four, eight. Two, two. Okay, get it? So this is what is a catalytic converter? What can be used as a catalyst? Usually, any transition metal. So they will use transition metals like cadmium and things like that. Okay, can? So cars just have to fix it before the exhaust to prevent the release of these dangerous gases. Okay. What about if it's a factory? It's that. Yeah, something like that. So they release sulfur dioxide. So what they can do to stop the sulfur dioxide is they do something called a flue gas desulfurization. Okay? Okay, desulfurization, flue gas desulfurization uses calcium oxide or calcium carbonate because this one is base and this one is acidic. So will it neutralize each other? Yes, it will. Mhm. Okay, can you write down the equation on it? Okay, this part is not your syllabus, but I think it's important for you to know. If you just add this together, what do you think will happen? Yeah, no water lah, so just add salt lah. Can you write down the salt? And can you try and name me the salt? I think you can. This is SO2. SO2, not SO3, SO2. Mm-mm. It's calcium, but not sulfate. Sulfites. Very good. Okay. So you will get CaSO3. Calcium sulfite. Okay, so it's just neutralizing it. You can also use calcium carbonate lah, but most of the time they use calcium oxide to neutralize the sulfur dioxide. Okay, so this is in the factory. You cannot do this in the exhaust, No, the exhaust is catalytic converter. This one is flue gas desulfurization. Okay, Ken? Ijo, do you understand?
No problem.
Okay. All right, so go back to our chapter here. Okay. Mm, okay. One more part I'm going to teach you is, okay, this part you're going to learn in bio as well. I'm only going to teach you the front part because the next part you learn in bio. Okay, so fertilizer can also cause pollution. Fertilizer is very important for plants because we want it to have high crop yield. That means lots of yield from the crops. Okay, so what happens is we need to have fertilizer, and the fertilizers that we must have to have NPK. You only need to remember one thing, which is NPK. What is NPK? No, nitrogen, potassium, and phosphorus. You got it confused as in this is nitrogen. This is phosphorus. And this is potassium. K is potassium, not P. P is phosphorus. Okay, so they will ask you things like, give me an example of NPK fertilizers, or which one is the best fertilizer. Okay? No, cow dung is natural fertilizer. Okay, Ken? So, sorry? So, for example, if I have ammonium phosphate. Okay, is this NPK? Look carefully. It has N and it has P, but no K. So they will ask you, if I have this, what else should I add in? So they will give you sodium nitrate or potassium nitrate or zinc nitrate or magnesium nitrate. This kind of question. So if I have this already, who should I add to make it a good fertilizer? And then you must choose potassium nitrate, like that only. You just need to remember in your choices of chemicals that you use, it has to be a salt. Okay, don't go and say, oh, which one is a good one to use, and then the question gives you this one, choice one, choice two, and choice three. Okay, which one can you use? Yeah, you must use this. Why you cannot use these two? Because they're acid and alkaline, you will kill the soil. Understand or not? So it has to be neutral, it has to be a salt, and it has to have NPK. Okay? Okay, that's all. That's all for today.